Hi, I'm Sam, and welcome to What the Heck is XSS and how to find it. So, I want to make this video because I feel like there's a lot of people that know what XSS is in the general sense, but there's a couple of details that they get wrong. So, what I want to talk about is what people get wrong with XSS, how to tell the different types apart, because that's also an area that I see people making mistakes in. And I also want to spend the second half of the video talking about how you can find XSS and tips and tricks on how to do it with black box testing, putting input and stuff, and code auditing, which is literally looking into source code. So the goal of this is I want you to walk away from this video feeling very confident in saying what XSS is and what it isn't, its variants, and how to find it. So first, of course, what is XSS, right? It's cross-site scripting. In plain English, it's a vulnerability where attackers can run JavaScript code in your browser through some vulnerability in the pager application or a client-side library, which lets you inject code. The impact of this is that they're able to do anything that the page can. Essentially, there is no way for the browser to tell the difference between the malicious script and what the web browser itself says is valid code. So the browser will treat them as the same, which means that the script can do the same thing. And this is almost always caused by a lack of filtering. So, bad data comes in and you don't do anything about that. And you also let bad data get outputted to the page. It's just going to be a bad time all around. What is XSS not? So, this is the part that I feel that most people get wrong. Just because there is some kind of web vulnerability involving JavaScript does not make it XSS. You are doing yourself a disservice as well as the program you're reporting it to by claiming that, because in some instances XSS can actually be a lot more severe than a normal XSS would be. A good example of that is a Node.js application where you're injecting some kind of JavaScript into the templating engine. That will actually lead to full-on remote code execution because now you're running JavaScript code from the much more privileged API that Node exposes to the JavaScript programs. Same thing with Electron apps, which are the code you're writing for them is much more similar to that of a normal web page, but the issue here is that Electron does have an API that exposes things like raw file access to the file system. You can spawn programs, and so it's literally just remote code execution if you get XSS in one of those. So I really encourage you that just because it's JavaScript and because it's using some kind of web technology, don't automatically go for the XSS label. Think about what the actual impact is and label it based on that, because that will help both you and the person that you're reporting it for. So the first type I want to talk about is reflected. So reflected XSS. In principle, it's quite simple. You have a client and you have a server. Now the server, of course, wants some kind of data from the client, and you're returning that to it. This is usually in the form of a HTML form. It can be in the URL or what have you. But in this case, I'm sending a string back to the server, which is script alert one and then end tag. So what happens in reflected XSS is that the server simply takes the value that I sent it and it embeds it in the response as part of the HTML. And because there is no way for the browser to tell that the inner script tag is any different from the outer HTML being provided originally by the server, and the inner script tags being provided by me, there's no way for it to tell them apart. So it treats the script as valid code and it will execute it, which means, in effect, I have control over the scripts that are in the page. Now, I want to highlight this. It does not have to be embedded in HTML to be reflected XSS. There are a number of different contexts in which JavaScript can actually execute in the browser. For example, an SVG image, believe it or not, can contain JavaScript. So can any XML document. And really, this is because HTML is also kind of a subset of XML. So you can think of any XML context will in some way be vulnerable to this. So if you have any kind of data injection into XML, you should be testing for XSS as well. But the important here to notice is that for reflected XSS, the XSS does not persist beyond us sending that data. It's a momentary interaction where the server is reflecting the data back to us, and that's what reflected XSS is. So here's an example. You have this example.com. I will show them as here, example.com and index.html. So this is simply a form which is going to send it to welcome.php, and it asks, what is your name? You provide your name, and then you press the submit button. So when you press the submit button, it'll simply send it as the get parameter name over to this URL. And as you can see, the server-side code also just gets the get parameter name and it embeds it into the HTML code. This is the same thing as what we saw in the little exchange earlier with data. Essentially, it's taking whatever data that we're providing in the momentary interaction and it's embedding it in the HTML that the server responding with. So this is very characteristic of a reflected XSS vulnerability. So the way this would be weaponized from an attacker perspective, right, is you would have this example.com, welcome.php, and then with the name parameter, you would simply swap it out with whatever XSS payload you wanted the victim to be subjected to if they visited the page. Of course, this would not say alert1, it would be pointed to something else, but you know that. So with stored XSS, you actually have two different data flows. The first one is an attacker has access to some kind of endpoint that stores data. In this case, it is a server that stores news stories in some way. So an attacker says, hey, I have a news story for you. Here's the headline, script alert one, and then end tag, right? And so the server stores it with a question. And then later on, when a client comes and visits the server and says, hey, what are the latest news? The server will simply echo the headlines back out to the page as they are. And that's basically how the stored XSS works, is you have two different data flows. And that's very important because if you only have that momentary interaction, again, it's reflected XSS, it's not stored XSS. So in stored XSS, an attacker is able to store the malicious payload. And this is how it might look. You have a submit article.php. Don't worry about reading it so much, but the important bit is this function here, process and store request, which takes a headline. And then for the sake of emulating it further, we have a filter bad data on the post body. Because what usually happens is that a developer will forget to sanitize one data input over another. And that's why it's always worth checking all parameters when you're doing something like this. And then down here, we have an echo statement, basically echoing a HTML saved article, and then it gives us the headline and then close tag. Now, I want to point this out. There's actually two XSS vulnerabilities in here. The first one is stored because it's taking the data and it's pushing it into a database unsanitized, so that when it gets reflected to the page later, it's also going to be unsanitized. I mean, I'll show you the code for that later. But the second line is reflected despite the fact that it takes place on an endpoint that stores data. You can have reflected XSS in an endpoint that stores data. This is something that I see people get wrong, and they label something like that as stored even when it isn't. So in this case, of course, you have the data flow. You send the script payload to the server, and it basically reflects it back into HTML. So this is, of course, reflected. And where the stored XSS really happens is when you later have a client visiting the server and asking for all the headlines with the links, which is represented by this line here. What are the headlines? And then it alerts it back. So with stored XSS, what you're really looking for is you're looking for two data flows. You're looking for the storing and the reflecting, which are separate. If you have them together, you are very frequently looking for reflected XSS, and that's what I encourage you to really think about calling it. So the third one is DOM, or Document Object Model. It's essentially a situation where you have a JavaScript library, and instead of interacting with a server, you are now interacting with some JavaScript code locally on a page itself. So it'll ask you with a prompt like, what's your name? and it says maybe Alice, and then it modifies the HTML on the fly to say hi Alice. There is no server involved in that exchange. So the document object model, and I want to go a little bit into detail about what it is because I feel like not everyone who does web is very comfortable with what it actually is. What it literally is it's like an API. It's an interface for your browser to understand and modify web pages. Um, like if you've used, like, I can just show you right now. If you've used JavaScript, like as I have up on the page, if you ever go to like type document or you go window like that, these are both functions defined in the DOM standard. They are like a very specific interface that is exposed for the browser to manipulate. That's why you have the document and window functions in every browser, whether it's Firefox, Internet Explorer, whatever. They all have it, and it's how the browser basically goes on and modifies the page on the fly. And of course, this is largely because if you wanted to make or if you wanted to modify a page on the fly from the browser's perspective, it would be insanely complicated to safely modify the HTML as text. Um, you would be looking at the code here on the left, HTML head, blah, blah, blah. And like, let's say you wanted to swap out the title. Well, the first thing you'd have to do is you'd have to parse each of these. You'd have to work out where they end. You'd have to then work out where's the beginning and the end of the string. And then you have to worry about, well, okay, well, what happens if we have multiple titles? Like, how do we deal with that situation? Or is this like, do we even count this one, or is that part of the title and is the second closing tag actually the real one? And a lot of other messy things like that. So what it does is it simply takes this document, the text, and it parses it and it creates this tree you see here on the right. You have the document node at the very bottom of it, essentially, or top, depending on how you want to see it. Then you have the root element, which is always this tag, of course, and then head, body, title, etc. So when the browser later wants to go and swap out the title, it can just go down and traverse down this tree, find the title tag, and swap out this text rather than having to worry about manipulating the strings and all the substrings and stuff like that. And it's very well defined how you parse it. And the reason I'm mentioning this is because in DOM XSS, the vulnerability exists in the client-side JavaScript code that manipulates the page. It's based on interacting with the DOM in a way that is unsafe, because there's ways you can do it where the browser will just interpret it as text or as HTML. Here's an example of a little vulnerable code. On window load, it'll simply ask us, what is your name? Load it into the name variable, and then it will find the first body element. Take note of that here, first body element. And then it'll use the inner HTML method variable, the inner HTML setter essentially, and do a string concatenation with this variable and write that as HTML to the source code of the page. This is subtly different from just changing the HTML itself. For example, if you put a script tag in the name variable, like script alert1 end tag, it wouldn't work. It doesn't execute because in the DOM model, it is actually defined that that doesn't work. Don't ask me why, I just know it doesn't. And the simple consequence of that is that there are some situations where you need to approach DOM XSS as different than you would finding reflected or stored, and it also has an impact on the payloads that you use to test for it, right? So yeah, DOM modification is not HTML injection, and you shouldn't treat them the same way. You want to be a little bit careful when you're doing something that is very heavily reliant on a JavaScript like client-side library, because it can modify how things work. So now let's get to the good bits. How do we find it? So there's two general approaches. There's black box testing, which is probably what you're familiar with, just inserting text into stuff, and there's code auditing, which is going into depth with the code. So we'll start with the black box testing, which is literally just shoving XSS payloads everywhere. There's some good ways and bad ways to do this though. So the best way to do this is you have to treat it a bit like a sprint. You want to test as much of the application as fast as possible, because what you really want to do is you want to try to get okay coverage on as much of the application as possible. Because when you're doing black box testing, there are situations that could happen where it's like the payload you're using to test for it is just not the right one. So it might be vulnerable, but you're just not going to find it because you're black box testing. And that's just something you have to deal with. So a much better usage of your time is to not worry about all those tiny little edge corner cases and instead just use like, a couple of good payloads and just identify all the places where the application takes input and just insert a couple of XSS payloads into these and keep an eye for the payload in the source code and basically just hope for the best, to be honest. But my point is that you do not want to spend a lot of time testing one parameter unless you have some good evidence to suggest that, maybe something is weird with it. Then of course, feel free to test forward. But if you're basically hammering the same endpoint, which is giving you no feedback, just move on. If you don't find it after changing XSS payloads a bunch and just trying different things, it's not going to be worth your time to keep hammering it, because more likely than not, the best place to look for these kind of weird things, XSS vulnerabilities, is going to be in some odd endpoint or like in a parameter that a developer just forgot to sanitize, which means you need to test every parameter of pretty much every endpoint. So if you didn't know, the best way of testing for these, at least in many people's opinions, including mine, is to use so-called XSS polyglots. And I encourage you to Google this if you're not familiar with the term. It is literally a little string that contains as many ways as possible to trigger XSS. It usually combines some very basic primitive ways of bypassing filtration and getting away with like a little bit of weirdness to it, so it's gonna work in more situations than it's not gonna work. And this is also because of what I was mentioning before with DOM, in that there are situations where it's just not gonna work depending on where you inject it. And XSS polyglots are meant to get around this problem by giving you a payload that will work in as many contexts as possible. So here's an example of a weird one, right? You have uppercase and lowercase JavaScript, a bunch of comments, on-click alert, on-load alert. It's a bit hard to know what's going on, but essentially what it's trying to do is just fit as many ways as possible to execute JavaScript into one string as possible. This is probably the first one you're going to encounter if you Google XSS polyglots, because it's called the ultimate XSS polyglot. But I want to point out that it's not perfect. You should have a couple of these, one for DOM, one for non-DOM, maybe one for stored, maybe one for reflected. You want to curate your own, a couple of these. It's not really very difficult to do. You just need to be aware that there are some situations where they're not all going to work. Perhaps you have a filter in your way that's going to block one kind of payload and not another. So it's worth looking for a couple of different ones of these just to play around with. Because, yeah, polyglots can fail. So don't just rely on one, get a couple of good ones and be in the habit of swapping them out. And as I mentioned, it is a sprint, it's not a marathon. You want to cover as much ground as quickly as possible. So, black box testing is much more of an art than it is a science, in my opinion. But there's a couple of good tips you can use. The first one is you want to use a proxy like Burp or Zap to keep detailed logs of all your traffic. You always want to persist it to disk, by which I mean you want to save all the traffic as a project in these tools to disk. And the reason why that's very important is quite simple. If you're looking for an XSS payload, it's not always going to be output where you expect it. You might have your username that you register to a page to show up on only one admin panel and like nested deep in the source code in a place that you won't even think about. And that's why it's very important to keep all these logs, because what you're going to do after you do a bunch of testing is you're going to search back for these payloads that you used and you're going to find where they showed up. Because of course, while you're testing, you're also keeping an eye out for like any obvious places that they show up, but you're going to miss a couple of weird spots if you just do that. You want to go through your logs afterwards to see where they show up, if anywhere. And a good time saver if you're doing that, if you're using a proxy, both Burp and Zap have a functionality called, well, in Burp it's called match and replace. I think it's called the replacer or something in Zap. It can basically swap out some string in the request with anything else. You can do it with the response too, but specifically this is for the request. So what you do is you swap out something like payload 1 and you make it so that the replacer will automatically always swap it out with your favorite XSS payload, and payload 2 with another one, and payload 3 with another one, okay? So when you're going around the page, you don't have to keep copying and pasting from your notepad or wherever. You can just type payload 1, payload 2, payload 3, etc., and keep doing that. And Burp or Zap will take care of swapping it out for you in the request and ensuring that it gets to the application. This saves you time because it means you don't have to set it up every time. You don't have to worry about where you saved your files. You can also much easier iterate on your setup to ensure that you're kind of iteratively working towards a payload setup that's much better for you. Another one that's also good is if you have an XSS polyglot or any kind of thing, include any kind of unique string into the payload so that you can use it to search for in the logs. Burp has this beautiful thing called logger++, where you can enter like any search string and it'll just search for it and everything. And this is gold if you're doing that, because you can easily use brute force and just insert it everywhere possible. And then in logger++, you can just enter that little unique string and it'll find it in every single page and it will miss nothing. I mean, I guess it could miss it if it's encoded in a weird way, like base64 encoded or even URL encoded, but either way, it's going to make it a lot easier for you to pick it up. Another one is you should also try out testing multiple payloads, as I said, because you don't know if there's some kind of like very dumb filter that's just filtering the most obvious one, but there might be another very simple payload that could get in. Like the XSS polyglot might fail, but script alert 1 could succeed. You want to try a different one. And despite this, you don't want to spend too much time on any one endpoint. As I said, you really want to try different places. Most XSS that you will ever find is actually very trivial. You'll just notice, be like, what? Why does this work? It's like you'll test the entire application, nothing's working, nothing's working, nothing's working, and it has very strict filtering and everything. And then you just find one endpoint, one API, one maybe even method of like a weird developer thing, and that one just has the world's easiest XSS possible. Those are the ones you usually see. So another one I also use is I use Google Site Operator to find other weird pages that the website has. This is especially effective if you're testing a company, like an actual business, because sometimes they'll have promotional pages where they have various parameters that they use to fine tune it. Like I've found one that was like it was basically a email opt-in page, and you had your name and your email, of course, that it could like auto-populate the template from. But both of those were vulnerable to XSS because it just did a string concatenation to write that page. But that didn't show up anywhere on the website's normal page. You had to use the Google Site Operator to basically look through, okay, where have people been in the past? What weird stuff do they have? So that's something that you could do to find pages that are less easily accessible, because those weird things, they're more likely to be buggy. The second way you can find XSS, and this is honestly the more effective one, it is much more slow, but it's more effective. And that's simply reading through the code. Um, if you have I don't know, some amount of code, you're going to find just a much larger percentage of any bugs that are in it by doing code auditing, because usually these kinds of bugs, they're actually relatively obvious if you know how to look for them. The crux is in knowing how to look for them, and of course the fact that it takes a lot longer, because if you have a large code base, well then it's of course slower than just running a crawl on it. And this is very much a marathon and not a sprint. This is about taking your time, being careful, and really checking everything that could be relevant. It's not something you want to like rush through and just go for the low-hanging fruit, because it's once you see the pattern, you'll know whether it's vulnerable or not a lot of the time, and it's simply worth looking into. So the most common approach to code auditing is based on following through the data in the application. And I'm talking specifically about, get requests, post data, etc. So you want to track the point where the data enters the application, which is usually the get or post parameter, and then snakes its way through the application. What functions does it call on the way there, or rather, what does the application call on the data, and then where does it finally end up? So there's two ways to do this. They're pretty intuitive when you think about it. First, there's forward tracing, which is starting from the inputs, And second one, there's backtracing, which is starting from bad code patterns. So one is starting from the get parameters, for example. Number two is starting from some very suspicious looking string concatenation near the output. So it's worth noting that when you're doing code auditing, both reflected and stored XSS require you to have the server-side source code. Maybe that seems obvious to some, but it's worth mentioning because if you don't have any kind of source code, the best you can hope for in terms of code auditing is DOM XSS, which can be quite complicated to exploit and demonstrate impact of. So in the situations where you don't have the source code, I mean, it's frequently much better to just do the full-on black box testing rather than trying to reverse engineer the JavaScript source code. That's not always, but generally. So here's an example. A little bit of code. In forward tracing, what you do is you start with the data and you try to find where it ends up, right? So in this case, we're looking for functions like window prompt, like up here, right? And the appropriately named function getName, which basically just takes the window prompt, returns it, and we can tell that this variable ends up here as name. It then gets filtered, and then it goes into the display function. Now, if we're doing backtracing, what we do is we look for output functions. Like we would look for strings like inner HTML or anything like that. And you would start from those points and you would go, okay, well, I can see we're concatenating with the variable name. Display takes the variable name. Where is the function display called? You can tell that comes there, that comes there, comes there, comes there. So it is very much forwards backwards because usually in an application, data flow is down the lines of code, and if you're doing the reverse, then of course you're just going backwards through the code. So both of these are very good, but they're good at different things. Forward tracing is a fantastic way to get good coverage because usually you'll have a pretty good idea of how the application gets its data into the program, right? Because if you have an HTTP application, that has like a GET request, and you can be sure that it doesn't have any POST requests, then if you know the language or the framework, then it's like, well, there's like maybe 3 functions they can use to get that data. In this instance, we would know that it's window.prompt. But basically, it's very easy for you to find every point where data enters the application. The downside is there can be a lot of data, and there can be a lot of not even false positives. There can just be a lot of wasted time because, like I said before, in a lot of cases, the developers will have sanitized data, but they'll just have forgotten it in one place, right? So in those instances, what you're doing is you're going to be seeing all of those safe usages before you ever get to anything bad. With backtracing, however, you're specifically looking for bad code patterns. So you're looking for usages of inner HTML, for example. So if you're using inner HTML, it's pretty much always going to be bad because there's very few reasons to ever use inner HTML over inner text, and to not do it in a safer way by creating actual nodes and appending them as children of other nodes. Whereas with forward tracing, you might end up with, I don't know, 100 different code branches. With backtracing in the same application, you might only end up with 2 different paths. The downside with backtracing is that you are completely dependent on knowing every single bad code pattern, right? Because let's say there was another function called, I don't know, inner XML, right? Just hypothetically. There is no such thing in the DOM standard, but let's say it's called inner XML. And I'm only looking for inner HTML. Well, I'm going to miss that completely really obvious other bad code if all I'm doing is looking for this. So it's a very good low-hanging fruit grabber, and it's a really good way to kind of get quick wins, but it can fail in situations, and it's important to not be fully dependent on backtracing if you want good code coverage, because you're going to miss a lot of subtle bugs. So both DOM XSS and stored XSS can be tricky to find. because the input and different output logic can be very different. And what I mean by that is usually with DOM XSS and stored XSS, I mean, not always, but sometimes you can have two completely different data flows for the input and the output, right? So in stored XSS, you might have the data being input, into a MySQL database unsanitized. That's simple enough. But if that data is later being used, exported to a CSV document, that CSV document is mailed to some other person who then imports it into their database, and then that database then writes it out as XML. Well, then it's still stored XSS, but clearly it would be very tricky to isolate that because you might not even have access to that, even though the vulnerability still exists. So in these kind of situations, what you really want to be thinking about is which of forward or backward tracing do I want to use? If you're doing stored XSS hunting, if I do forward tracing and the get parameter just ends up in a database, well, then that doesn't really tell me much. But what tells me something is, okay, well, some data from the database is now ending up into a dangerous function. So in those situations, backwards tracing can be significantly more effective than forward tracing. Same thing with DOM XSS. But DOM XSS is actually even trickier because here's just a small number of different ways that DOM XSS can read data from the user, right? First one is just a little prompt window. Second one is a jQuery, which is an AJAX request to another page, which gets data from it, so like any API. The third one is getting it from the URL. The fourth one is getting it from a database. The fifth one is parsing it from the cookie, from the local storage. You can do the event messaging and post message passing between iframes. You can get it from that user agent. You can also upload files, etc., etc., etc. Some of these are very easy to weaponize, like the URL, where you can just send someone, a URL with some bad data in it. But if you find an XSS which is in a file input, then it can be a lot trickier, right? Because if the logic is in the JavaScript, then even if you set up an attack which sends a file to that page, then it doesn't really do anything because the server side page doesn't do anything. It's just like a placeholder file input on the page for the JavaScript to hook into. So you can't really weaponize that. And similarly, it can also be difficult to know exactly what output or sync functions are safe or dangerous, right? So for example, old versions of jQuery would eval any script you requested with it. So if you did like a jQuery get data.js, it would just eval that script. And this was, as far as I understand it anyway, basically a way to get JSON data back very conveniently. It was a way to basically evaluate code and make sure that you can easily load code that you would need dynamically, which might sound good in theory, but when you think about the fact that you're evaling literally any script, it means that if an attacker gets control of jQuery, they can now eval any script they want. So third-party libraries might do something like call React's dangerously set inner HTML. And this is just React literally calling that dangerous inner HTML function I called before. And that's bad, obviously, because if a developer is using this third-party library and that third-party library in turn is calling set inner HTML, then it's the same thing as if the developer had done so themselves. But it might not be obvious because maybe they're just depending on it as like a kind of auxiliary module, but nonetheless, you could still be vulnerable to XSS just from that third-party library you're using. And some frameworks do not handle things well that you would expect to do. For example, there's quite a few frameworks, even at this moment, as far as I'm aware, that do not handle the JavaScript colon kind of data well if you put it in a link tag, an A tag. I don't know exactly what to call it, but the tag that is a link, right, with an href, and then you have the JavaScript colon, so that when you click on it, it executes the JavaScript. And that's not something you might expect unless you're very familiar with what the framework is doing. So if you now are allowing, I don't know, users to inject some data into the URL, like maybe it's a BB code kind of thing where they're allowing people to embed code onto the page so that they can link people to their favorite sites. Well, now maybe there's a way for someone to include a JavaScript tag and execute XSS that way. And the data sanitizers that some of these libraries depend on, like DOM Purify, which is a very mature library, by the way, they've had bypasses where you can just inject some code into this and it'll run. And this is called mutation XSS usually, because the way these DOM sanitizers work is they're quite good at doing what they are meant to do with well-formed data. But if you feed it data that is bad in the sense that it's broken, then sometimes what the browser will do is it'll try to repair the data, because developers don't always write conformant code. And so DOM Purify will look at it and go basically, hey, this looks broken. There's nothing for me to fix. It just outputs it as it is. And then the browser will go, hey, I should fix this. And then it fixes it, and the fixed payload is an XSS payload, even though the original broken one isn't. So that's called mutation XSS, and that's an example of things that DOM Purify has historically been horrible at dealing with. And you can also deal with things like file uploads, right? An easy way to miss a stored XSS is if you're not protecting your file upload endpoints, again, for example, XML or SVG or HTML. Because if you can upload any of those, well, then you have basically the ability to upload any web browser pages. So the crux of this is you often need good library knowledge to reliably find more subtle XSS. To find the low-hanging fruit, usually with code auditing, it's really easy because all you got to do is look for the bad functions via backtracing through the code, which is like inner HTML. You want to look for just string concatenation in general, especially in or near HTML code in general. You can just look for angle brackets. And it's different if you're looking for subtle XSS, where I'm talking about those like very long chains of data flow, because you might need good library knowledge to know whether it's exploitable or not. So what I really recommend to do, if you want to get good at it fast, is I would encourage you to make a vulnerable application using Angular or React. Like, damn vulnerable web app, there's WebGoat, there's Juice Shop from OWASP, etc. There's all these kind of vulnerable applications. But if you make your own, it's actually a really good exercise, especially if it's a front end heavy application, because you're going to learn how to emulate the bad code patterns that lead to these vulnerabilities. So yeah, knowledge is everything when it comes to code auditing. So some general tips for code auditing. To begin with, grep for any keywords associated with data, like post in PHP, or sorry, $_post in PHP, request.get for Django in Python, for example, right? Because what I've found sometimes is I've found XSS or even SQL injection just by searching for these and seeing like the following 2 lines of code, because sometimes they will literally just take the post parameter and they'll just pass it to some SQL thing with a string concatenation, or they'll just feed it into the body of the HTML directly. And so sometimes you can get these very low hanging fruit very cheaply just by using grep. So you'd use like grep and then recursively and then case insensitive, and then you'd use the little keywords that you have here like post and request.get together with the parameters that allow you to see maybe like a line or two afterwards, and that'll actually score you some quick wins in very bad projects. To quickly find data output points, I recommend you look for functions that manipulate HTTP response headers. You can sometimes find these by searching for the strings themselves that are the headers, like, I don't know, content security policy, or, all those. Because usually you have to set them very close to where you do the output, because these libraries don't have good ways of knowing what is the intended use of the endpoints that they're exposing, right? So you have a serve file function and it loads a file. Well, you might still need to disable or enable content sniffing. You might need to set the file type specifically. So when you're seeing these response headers being manipulated, you're pretty sure that you're close to an output. So another low-hanging fruit, grep for direct string concatenation. This can provide a lot of output because people use string concatenation in a lot of places, but usually they're very fast to go through, and it's really obvious if they're doing something they shouldn't. Because in most cases, when someone's doing, for example, XSS, something accessible, I guess, they'll have a variable name called like response body or like response or something similar, and you can get a lot of hints just from the names of these variables that they're using. I can't tell you how many SQL injections I've found just because
I've noticed that in a string concatenation, it was like SQL underscore query as the string that they were concatenating with, which is like, okay, pretty obvious stuff. So this one's maybe very obvious, but you also want to use the application beforehand to understand the application flow. Code auditing is very labor intensive, by which I mean you're going to be looking at every line of code in the application, and the point at which you're going to perform best is when you actually understand what the application is doing, why, how, what's the framework doing, what are they using the framework for, how can the framework fail, etc. Like deep understanding of it. So to really speed that up, you really want to use the application and understand what it's trying to do, how is it doing it, like what endpoints appear buggy and why, or like poorly developed. Just seeing some part of the application that doesn't look well developed yet, like a new endpoint or something labeled beta, can give you a great idea of a place to start looking. And the final tip is, if you can, use an IDE and a debugger and breakpoints. Like if you have a Python code base, like literally just load it up into your favorite IDE, spin it up, and put breakpoints on things you want to investigate. If you can send data through and then you can kind of break it and you can see what's happened to the data when you get it and you can see it in your IDE, that is an insane time saver for verifying whether your assumptions are correct or not. Because sometimes you'll have a situation where you think something is vulnerable, but there might be some function decorators. It's basically a way to have a method process another one, like a function process another one very, very easily with like a single line of code above the method definition. I know I don't have anything on screen to show what this is, so I'm sorry that's confusing, but essentially it's very easy to miss some ways that data is processed sometimes. You can even have like implicit detection of like what is your OS type, and then there's some like weird branch in the code that goes somewhere you don't expect it to, and it's not exploitable for one reason or another. So having the IDE and the debugger set up can save you a tremendous amount of time because it lets you validate your assumptions. And we're getting very close to the end now, but I just want to assure you that if you use these methods I've underlined here, you will find CVEs and you will find bugs. I have, and I will continue to do so. And the simple fact is, it's not very difficult. All you need is persistence, and you need to have a decent technique so that you're not spinning your wheels on wasting time on things. Like a lot of beginners will go into an endpoint that says, like, I don't know, dev debug, right? And they'll test every parameter possible and spend days testing it. But debug dev, if you test a few things on it and it's not working, just move on to something else, because that's an indication that the developer is guarding that endpoint because they know it might be vulnerable, or not vulnerable, but it's sensitive. So, it's those beginner things that you can really get caught up on. So if you follow these tips, I guarantee you will find bugs. Thanks for watching. This is my first video I have made in a freaking long time, so I hope it wasn't completely awful. If you want to, I don't know, follow me on Twitter, that would be great. You can also join us on Discord at hackd.community. It's a new community, but you are more than welcome to join. And I look forward to putting out more of these videos in the future because I enjoy doing it. I am just terrible at it. So, again, thanks for watching and goodbye.